In this example, a student is standardizing a solution of sodium hydroxide and finds that 28.15 mils of that solution is required to neutralize 25.00 mils of a 0.1072 molar standard solution of KHP. So the student is using KHP, a primary acidic standard, to determine the concentration of sodium hydroxide to a very precise and accurate amount. So one thing that's going to be a little bit new for us is because we're working with volumes in the milliliter range often with titrations, it's useful to work with concentrations rather than in molar, work with them in millimolar. So concentration of molar is moles per liter, millimolar is millimoles per milliliter. And so you're essentially dividing each of those units by 1,000. So the concentration, we would say, is 0.1072 millimoles per milliliter rather than moles per liter. So we've just divided each unit by 1,000. And so that's going to save us a step rather than having to convert from mils to liters every time. Okay. KHP is a monoprotic acid, so as we can see in the reaction, it's a one-to-one reaction. And so what we're going to first determine is the number of moles of KHP that were added. And in fact, we're going to figure out our millimoles. So our millimoles of KHP would be 25.00 milliliters times 0.1072 millimoles per milliliter. And so that works out to being 0.002680 millimoles. Okay, so that's our millimoles of KHP. And so at the equivalence point, the millimoles of of KHP is going to equal the millimoles of sodium hydroxide because it is a one-to-one ratio in the reaction. And so our millimoles of sodium hydroxide is also going to be 0.002680 millimoles. And so finally, our concentration of sodium hydroxide then would be 0.002680 millimoles, which were in our sample of 28.15 milliliters. And so that equals a concentration of 0.09520 millimoles per milliliter, which is the same as molar.